Welcome to the DIY Honda Garage channel. Welcome to this troubleshooting guide for DTC P0193, indicating a high voltage issue within the fuel rail pressure sensor circuit of the Honda Accord 2023 and newer models. The fuel rail pressure sensor plays a critical role in monitoring the fuel pressure within the fuel delivery system to ensure efficient engine performance. Its output voltage provides critical data to the Powertrain Control Module, PCM, which uses this data for fuel management and optimizing engine operation. When the output voltage from the sensor exceeds specified thresholds, the PCM detects an anomaly and logs the DTC, signaling that something is amiss in the system. Understanding how to effectively troubleshoot this code is essential to restoring the vehicle's optimal functionality while ensuring that you're adhering to Honda's procedures and standards. Let's dive deeper into the specifics of this error and learn how we can resolve it effectively. The DTC P0193 indicates a potential malfunction in the fuel rail pressure sensor, which is integral to the fuel delivery system. This sensor is usually located on the fuel rail, monitoring the pressure of the fuel to ensure proper fuel injection timing and volume for engine optimization. The Powertrain Control Module, PCM, relies heavily on accurate readings from this sensor to manage fuel delivery and maintain efficient engine performance. If the sensor output voltage exceeds the expected range, it can lead to improper fuel regulation and engine performance issues. Additionally, the PCM interprets this high voltage as a fault condition, triggering the error code P0193. Proper diagnosis and addressing of the issue are essential for the overall health of the vehicle's engine and fuel management system. A few possible causes for DTC P0193 include a faulty fuel rail pressure sensor, wiring problems, or an issue with the Powertrain Control Module, PCM itself. A defective fuel rail pressure sensor may incorrectly report pressure, leading to abnormal voltage output and subsequently the P0193 DTC. Additionally, any open circuits or shorts within the wiring that connects the sensor to the PCM can lead to inaccurate voltage readings. If the wires exhibit significant wear or damage, they can also contribute to high resistance and faulty signals. Lastly, if the sensor and wiring appear to be operational, one must consider the possibility of a malfunctioning PCM, which may not correctly interpret the sensor output. Each of these components must be investigated methodically to determine the root cause of the issue. When DTC P0193 is present, several symptoms may manifest during everyday driving. One of the most immediate indicators is a noticeable decrease in engine performance, often characterized by sluggish acceleration or rough idling. Drivers may also observe the illumination of the check engine light on the dashboard, signaling the need for attention regarding vehicle health. Additionally, as fuel delivery becomes increasingly inaccurate, increased fuel consumption may occur, which can lead to higher operational costs over time. These symptoms underscore the importance of diagnosing and resolving the underlying issues associated with DTC P0193 promptly, as neglecting them can exacerbate engine performance and fuel efficiency problems. Begin the troubleshooting process by turning the vehicle to the on mode and waiting for approximately 2 seconds. The high-definition scan tool, HDS, is vital in retrieving real-time diagnostic data. Once the vehicle is in on mode, check the HDS for the fuel pressure converted from PF sensor voltage reading. If this reading exceeds 4.89 volts, it confirms that the failure is indeed duplicated and the DTC P0193 is warranted. This step is crucial for agents to ascertain whether the sensor or the associated wiring is at fault before proceeding to further inspection steps. Monitoring the HDS values allows for early identification of potential sensor failures or circuit abnormalities. For the next step, first, ensure that the fuel rail pressure sensor connector, often a 3-pin connector, is disconnected. With the connector removed, use a jumper wire to bridge terminals number 1 and number 2 on the fuel rail pressure sensor connector. Next, turn the vehicle to the on position once again and observe the reading on the HDS. In a normal operational state, the fuel pressure converted from PF sensor voltage should read less than 4.89 volts. If this condition is met, it indicates that the fuel rail pressure sensor is faulty and it needs to be replaced. Conversely, if the value is still high, the problem may lie elsewhere in the circuit, necessitating further inspection. In this step, the focus shifts to inspecting the integrity of the wiring connected to the fuel rail pressure sensor and the PCM. First, disconnect the PCM connector B, ensuring that you have jumped the SCS line to prevent unintended damage or diagnostic errors. After disconnecting the PCM, it is essential to check for open circuits by testing the PF signal wire and the SG1 ground wire using an ohm meter. A normal condition here should show less than 1 ohm of resistance for both wires. If the readings are higher, there is an open circuit or wiring fault present. Addressing these wire issues is paramount, as they can lead to erroneous sensor readings and trigger DTC P0193. After inspecting the wiring for both the fuel rail pressure sensor and the PCM, the final step involves an inspection of the PCM itself, if all other components have been determined to be functioning normally. If previous tests have confirmed the sensor and wiring are operational, then it can be inferred that the PCM may be faulty. Confirming this involves looking at potential signs of physical damage or malfunction within the PCM, as well as verifying that all connections and settings are correct. If a PCM malfunction is established, it would need to be replaced or reprogrammed, ensuring the vehicle returns to proper functioning. This step emphasizes the importance of methodical diagnostics. Always rule out other components before concluding that the PCM is at fault. Following the completion of repairs based on preceding diagnostics, it is essential to verify that the issue has been resolved. Start by using the HDS to recheck the fuel pressure converted from PF sensor voltage values post-repair. The readings should show values less than 4.89 volts, confirming that the system is now functioning as it should. It is also prudent to review any repair logs to ensure all recommended actions were performed correctly. Finally, taking the vehicle for a test drive is crucial. This practical check allows for validation of repairs under normal operating conditions, ensuring that the DTC P0193 does not reoccur. The objective is to restore the vehicle to its optimal performance level. Preventive maintenance is a vital aspect of avoiding future issues related to DTC P0193. Regular inspections of the fuel rail pressure sensor can help identify potential problems before they lead to complete failure. It is also essential to check the condition of all associated wiring to ensure no wear and tear that can result in high resistance or shorts. Periodically running diagnostics on the PCM can help identify early signs of malfunctioning components. Taking a proactive approach concerning maintenance can significantly extend the lifespan of the fuel delivery system and associated control modules, thus improving overall vehicle reliability and performance. In conclusion, DTC P0193 revolving around the fuel rail pressure sensor circuit highlights the importance of accurate fuel pressure monitoring for optimal engine operation. Understanding the functional role of the fuel rail pressure sensor, the PCM, and the associated wiring is essential for effective troubleshooting. Following the outlined, stepwise troubleshooting process ensures no component is overlooked, leading to accurate diagnostics and repairs. Additionally, adopting preventive measures can help mitigate future issues, avoiding the recurrent appearance of the DTC P0193. Stay diligent in monitoring vehicle performance, and always refer to manufacturer protocols for diagnostics and repairs to ensure adherence to best practices. Please like and subscribe to the channel. See you next time.